So one thing I hadn't realized is that the last video I made was the end of Unit 4. I think just because I changed recording styles. So if anybody needs me to kind of do a once over of the unit activity, just let me know because I was getting into it and I realized, oh, I still need to do the unit activity for that. So if you guys need help with the unit activity, let me know. I don't usually go over the post test, so that's just a summary of all your notes. So let's get into Unit 5. All right, so Unit 5, so we're going to be covering systems of linear equations, and the system of linear equations just means more than one line, basically. So if we have one linear equation here and another one here, we're going to be trying to figure out where these two meet each other. What's the x and y value of where these two things touch each other? That's what's known as the solution of it. So you're going to have an x and a y where these two lines touch each other. All right, so let's get into this. Let me erase the board here. So our goal here is to write and graph system of equations to determine the solution. So we're going to write down the equations. So we're going to do y equals, let's have a visual aid here, y equals mx plus b. And for both lines, so we're going to have one line and two lines. This is where function notation comes into play. If we have two lines, we might want to, instead of writing y equals, we're going to write f of x. So the first function and the second function equal, and it's going to be some type of m. We're going to call this m1 x plus b1 m2x plus b2. And the only reason why I'm numbering them like this is this slope and this slope don't necessarily mean that they're the same thing. And this b and this b aren't the same thing. The x just kind of free falls because we don't, this x can be anything. So we kind of don't really have to determine that. This m is a specific m. So moving on here, we got everything that we're going to learn. And sorry, I just had to clear the board. So let's do a warm up. So this warm up, we have this equation and this equation. So what we're doing here is the amount of coins in this guy's pocket. So suppose you have, I guess the coins in your pocket. So we have one equation where our y equals coins in pocket. And this other y over here, this is the amount of money in your pocket. They both have to do with the coins in your pocket, but one of them has to do with just counting the coins, how many pennies you have and how many quarters you have. That's why we have pennies and quarters. The other one has to do, represents how much that money is worth. So think of this kind of as saying your C of X, the amount of coins of X based of this. I guess it would be P of Q. So that's what this is representing. So the first equation, again, just represents coins equal this. Coins equal your pennies plus your quarters. And then your money is equal to 0.01. A penny is 0.01 of a dollar. And then a quarter is 0.25 of a dollar. So the other equation represents how many dollars you have in your pocket using decimals. So if we're doing this, the number of coins in your pockets. So evaluate the expression. We have 6 quarters and 11 pennies. So 7 pennies plus 6 quarters. So the total number of coins we have in our pocket is 13. The next one, we kind of have to do a little more work. Not even kind of. We have to do more work. So we're doing 0.01 times the amount of pennies. So 7 pennies. So we're going to multiply it by 7. Plus we're going to do the amount of quarters. So 0.25 times the number of quarters, which in this case is 6. So if we do this, we get 0.0. Oops. Want to stay a little consistent with my colors here for you guys. Sorry about that. So this is 0.07 plus, we're going to add our quarters, which if we have 6 quarters, this is why I'm able to do times 25 easy. If we have 6 quarters, that's $1.50. So in other words, we're going to have $1.57 in our pocket. So $1.57 in our pocket. So 1.57. That's how much dollars we have in our pocket. They say money, but they mean it in dollars. So that's why it's the amount of coins and the amount of money, how much money it's worth. So if we were to graph these two lines, oh, I should have just used, boop, there we go. So if we were to graph these two lines, we kind of have these two. So in this case, they decided to make quarters our y value. So if we graph this, our graph kind of looks like q equals 13 minus the pennies. Or in other words, we have a negative slope and an intercept. Our b is 13. So our intercept is 13. And we're going to go down 1 over 1. And if we do it for quarters, well, it's a little more complicated than that. What's going to happen is we have 0.25 times the quarters equals negative 0.01 p equals plus, because I'm subtracting this 0.01 p from both sides, plus the 1.57, and then I have to divide it by q. So it is a lot different here. So that's how come it's a little more, you can't see the slope that much because our slope is negative 0.01, because that's what we had over here. So they just graph it, just trust their word for it. All right, so now we're going to do it with other types of equations. This one, again, they're talking about the system of equations, two lines intersecting. If we wanted to solve it, the only place that these two lines equal each other is at this point. So even if we didn't know how many pennies and quarters we have, based on these two equations, they should have only ever met at that. There's no other situation where you can have 13 coins and have this, and have that many quarters and pennies. So if you have 13 coins and they're all quarters and pennies, and you have $1.57 in your pocket, the only way for you to get $1.57 with 13 pennies or quarters has to be this. So, and then we can plug it in. So if you plug in your 7 and your 6, you find out that it works. So this is the same thing. So the x in here and the x in the other equation equal each other. That's another reason why I didn't do the x of 1, x of 2, because when we're solving for the answer, when we're solving for this, it's going to be the same x and the same y. We just need to figure out what that x and y are. So if we're doing this one, we have this weird method. So there's two methods of solving. You can do it by, or three methods. You can do it by graphing. That was the easiest, but it's a little harder when you get really specific. Or you can do it algebraically. So what they're doing here is they're making all of them equal. If you look at the work here, they make it equal to y. Well, this is equal to y, and then they're going to make the other one equal to y. So what they're doing here is they're solving for y, and then in the very next step, what they do is they're going to make these y's equal to each other. So essentially what they're doing here is they're getting ready to just graph this. So far in this unit, we're going to just learn, or in this module, we're going to learn mainly about solving a system by graphing. And the easiest way to solve that is to solve for y and get it in points or slope intercept form. Although in this case, our intercept is a weird little fraction. So it's a little harder to see here, but For the most part, you're just going to be using technology to solve it. We've already gone over how to graph and everything. They're going to give you more complicated equations, but you're going to use technology to figure it out. So now let's solve by graphing. All right, so we're going to take a look here, and we're going to use our graphing tools. So they gave us nice equations here to graph. If you guys are still having trouble kind of understanding what to do, I don't think Edmentum blocked out. Yep, they did block out your graphing calculator here. So you do have a graphing calculator to help you solve it if you're struggling and you need that extra help. The only downside is you have to plug it in yourself. But hopefully you understand how to do this at this point in time. So the first thing, I want to do my first equation. So I'm going to start at my intercept. So I'm going to plug a point at my -5. And according to this, I have to go up 3 over 1. So I'm going to start at -5. I'm going to go up 1, 2, 3. I'm going to go over 1. Boom. Perfect. Now, the next one I'm going to do here is I'm going to do this formula. I'm going to start off at 5, but in this case, I'm going to go up 1 and I'm going to go over 2. 1, 2. And I see that my point of intersection is right there. And I don't know if this one requires me, some of them require you to actually mark it. This doesn't look like I have to mark it. They're literally just telling me to graph it. Cool. So I'm going to submit that. It's going to tell me I'm correct. And now I'm going to do it again. So what's my solution to this? So if I look here, my solution here, the x value is 4 and my y value is 7. So I'm going to say, make sure you do in parentheses, 4, comma, 7. And I put a space there. I don't know if it's going to like the space. It should be fine with the space. So make sure you put your parentheses and you put that space there. All right, so now we're going to graph something a little more complicated. This one, they're actually giving you your graph tool. So this is what I meant by we're going to be using technology. So what I'm going to do here is I'm going to do copy this. I'm going to go into relationship. I'm going to do linear. Oops. Oh, I don't want to do linear. I'm sorry. You have to do relationship custom. And you can literally just type it in here and it should be able to plot it. Yep, plots it in just fine. Then I'm going to grab this one. So I'm going to grab this formula, go to relationship and custom, and I'm going to plot it. Okay, so this one's having trouble understanding it, and that's fine. What we're going to do here, since it's a little easier to do, I was wondering if Edmentum was going to do anything about this. This is actually pretty easy to solve by hand. So they're like, no, 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 you can solve that. You can do this easier. So I'm going to take away the x from both sides. I'm going to take away x from both sides. I get -3 y is equal to -x minus 15. Then I'm going to divide by -3. Everything by -3. So this becomes y is equal to x over 3, because the negatives cancel, plus 15. So let's see if Edmentum's a little more okay with this formula. I'm going to graph this, go to linear. Oh, not linear. I keep doing that. Well, I guess I could do linear. Oh, I don't want to do linear though, because divided by 3, 1 over 3 is a weird. It's going to be a very weird. Um, how can I say this? It's going to be a very weird m, because our m is essentially 1/3, because x over 3 is the same thing as 1/3 x. So it's a very weird one. So what we're going to do here is, oops, I got rid of everything. Luckily, I remember what it is. And you guys could just rewind if you're watching at home. Y equals x over 3 plus 15. So let's see how nice this is going to be to us. So y equals, do the fraction, x over 3. If this doesn't work, I'm going to try the 1/3. But I have a feeling this should work. Plus 15. Got it. I don't see it. Zoom out. Oh, there we go. So we had to zoom out for that one. So as we see here, what's happening is they intersect, but they intersect at the negative. And that's fine. Sometimes you get negative. Sometimes negatives are not appropriate answers. So let's put that in. What's going on here? Oh, make sure you guys do it the right way. I forgot to divide by. I only divided by x. It's supposed to be plus 5. I was wondering, I was like, it's weird that it's that zoomed in, but it's not where I want it. So y equals, and apparently Edmentum's not too picky if you get the right answer on this one. They're just like, yeah, sure, why not? Plus 5. It would have cared once we would have had time to do the actual answer, so I'm going to have to zoom back in here. Moving this over. So it's some weird fraction here. And you can see it right here. So the lines on the grid in part A don't intersect at two whole numbers. Estimate the values to the nearest 1/4. Then substitute x and y into the things. Okay, so we are estimating and to the nearest 1/4. So what I'm going to do here is I'm really going to zoom in here to get our estimation. And if we look, I think it's 3/4. So it looks like it's 6 and 3/4. It looks bigger than 1/2. That's why I'm guessing for the x value. Where's my thing? For my x value, or I'm sorry, my y value. My y value, I'm going to guess is equal to 6.75, 3/4. They want us to do it by 3/4, right? And then our x value, let me zoom in a little bit more. Go into my mouse mode, zoom in a little bit more, move this over. I'm going to drag this here. If we look, that looks like, it doesn't really look like 1/2 yet. See how this is 0.5? Because this is 5 right here. So this is a half. So because it's not at the halfway point, oh shoot, I just realized this isn't at the halfway point either. They are really getting tricky with these. I'm sorry, guys. I thought this was our 7. So since this isn't our 7, I'm going to say that this, we can guess either a half, because it's really close to half, or a half of a half, which is 0.25. So I'm going to do 6.25 for my y. Y equals that. And for my x, I'm going to say it's going to be 4.25. They want us to guess base closest. So I'm going to guess those, and we're going to have to type those in. So our equation, here's the cool part. We can pick either equation to plug it into. I'm going to plug it into the easier one. So it says approximate the values and of the two solutions, how close are the numbers in each equation? So we have to plug it into both of them. Oh dear. All right, so let's plug it into both of them. Unfortunately, they want us to plug it into both of them, so it's going to be 1.15. We're going to plug in our x, and our x is, I said, 4.25. Close the parenthesis. I'll use a calculator to solve this for you guys. Don't worry if it looks bad. And then I'm going to do this plus 0.65, plus 0.65, and it's going to be parentheses y. Our y value is, what was our y value? Our y value is 6.25. I'm going to do 6.25. And according to this, our answer should be something like 8.9. 8.9. 9D if you really want to have that there. Our other equation I just realized I should have made a table, but that's fine. So our other equation is going to be, I'm going to write it out the long way. I just realized I should have done this. This just makes it a little easier to kind of read it out. And one thing I didn't realize is I could have just copied and pasted it, so I didn't have to keep going back and forth like that. And here I'm going to plug it in. It also makes it easy to see what we're plugging in. So I'm going to plug in my x, which is 4.25 is what I'm guessing. And then for my y, don't forget my minus 3. Put some spaces here to make it easier. Minus 3 times, what's our y? 6.25. And they're saying this should be really close to negative 15. So let's do this. So I'm going to use the little calculator here. You don't even have to go that far for it. You can just use this calculator. So 1.15 times 4.25. And I'm using the buttons on my keyboard to kind of solve this. So we can approximate this to basically be 4.9. So what I'm doing here, is I'm basically just figuring out this part right here. So that's where I get that 4.9. So when I plug this in, I'm going to say this is 4.9. Let me get specific. Why not? I mean, we're using calculators. It's okay to be a little specific here. And then I'm going to do this part right here. Oops, I didn't mean to do that. I'm going to do highlight clicks. I was hoping there was a way I could do this. Focus on mouse. This part over here. Not a big fan of that one. Um, I'll just use a pen. This part. Okay, so I'm going to do that part. So here I'm going to do 0.65. Oops. Clear this out. Make sure I'm in the actual calculator. 0.65 times, if you did the times button, 6.25, and I get 4.0625, and this should be equal to that. Let's see if this is equal. I'm going to work the whole thing out. And then I get 4.8875 plus 4.0625. Oh, I got really close. Look at that. Look how close that is. It's not equal to, but I'm going to put it because it's supposed to be equal. Let's try the other one. Let's see how close we are there. So 4.25, there's nothing else there, minus whatever 3 times that is. So minus 3 times 6.25, we get 18.75. 18.75 equals negative 15. Move down here. Let's see how close this is. I have a feeling we're pretty close as well. 4.25 minus 18.75, 14.5. So we got negative 14.5. I probably could have done better, but considering they told us to guess based off of quarters, meaning 0.25, I think we were pretty close. So when we do this, we're going to say the first equation was off by 0.05, really close. And the second, I was off by 0.5. Okay. So I would say the hardest part was having to rewrite the formula. So I would give myself a 4. Changing to y-intercept form was pretty tough, you know? Just write something like that in. So let's submit all this so we can go to the next one. They can give you a sample answer. So they tried guessing a little bit differently. They guessed zero 0.5, I guess 6.25, but you can see that they were a little off. So they were off by 0.25. So they guessed a little better than me because this one's not that much. This one's even less, a lot less than what I did here. So they did pretty good guesses. All right, let's go to the next one. All right. And when we're doing this, all right, so they're just showing the work on how to do it with the actual answers. So they use technology to figure out the actual answers. You can use that with like Desmos and stuff. I've done it with Desmos. All right, so we're going to try to figure this out. So let's graph these relationships. Luckily, they already gave it to us in y-intercept form, so we should be able to just copy and paste these. Paste it. I don't know why. When they write it, I feel like they're hypocrites. Because when they write it, they have all these spaces. They want you to do it. They're like, we don't want any of those spaces. Like, why would you put those spaces there? We have that. And I'm going to plot it. Why aren't you saying it's correct? Relationship custom. I'm just going to type it in by hand because apparently Edmentum's giving me a hard time here. There we go. I don't know why they gave me such a hard time. Let me do it again. I'm going to do custom just to make it easier on myself. You, I think they want you to do the linear, but they give us the option to do this. So I'm just going to type it in by hand. It's so much easier. If you do the linear one, this is, to me, it's kind of annoying because you have to like adjust this by hand and then adjust this by hand. And you can't even get the native 2.5. So that's why I don't bother with the linear ones. They gave us the custom one for a reason, is what I say. All right. And they said I did that right. And it looks like they marked it. Later on, you're going to have to mark it. But for right now, you're good. All right. So there's 3 situations. I believe we went over this last time. There is parallel lines have no solution, meaning that they don't touch each other. They cannot touch each other, so there's no solution. They do not intersect. One solution, meaning that they intersect in one spot, or infinitely many solutions. If they're the same line, so you can see here, all they did was they just multiplied the line by 2. When you multiply a line by 2, it's still the same line. It just, since we're dealing with all of infinity, it doesn't really change where we're going. So what's happening here is it's the same line, so every single point is the same. Infinitely many solutions. Every point you can think of is a solution. So this solution is equal to itself, this solution is equal to itself. They're always touching each other. All right, so moving on to this. So we're going to graph this and write down how many solutions. So we have infinite, one solution, or no solutions. Well, these, it looks like the lines touching each other. So that's infinitely many. It's the same line. These ones, they cross each other one time. They're really close, so it looks like they might cross each other more, but lines can only cross each other either once, never, or always. That's the way I remember. Once, never, always. And these 2 parallel lines can never touch. They'll never touch each other. This one, they're touching each other one time. And I know this is a little harder. I have a little mouse with a wheel, so that's how come I'm able to go. Otherwise, I think what you have to do is click it with your finger and drag it up and slowly keep dragging it up until it lets you do it. So let's check our solutions. Boom, they're all right. Great. Moving on here. So modeling, with a linear system. All right, so let's take a look here. I'm going to be modeling with a linear system. So there's a few possibilities we have here. So no change in points for answering the wrong question. So if you're getting a question right, so I'm going to do it this way. Or they'll probably do it, but the idea here is we're going to figure out how many points she can get. So she got a score of 500. So we're going to figure out how many she got altogether. So looking at this question, she's answering 20 questions. So there wasn't any that like she didn't answer. She answered all 20. So it shouldn't change her score. There's no way we have to worry about this one. So she either gets 100 for getting it right or negative 200 for getting it wrong. So let's figure out how we can use algebra to do this. And I'm not going to do a video within a video, so you guys can watch this on your own. All right, so now we're going to figure out our equations. Well, our first equation is going to be for, there has to be an equation for questions. So there has to be an equation for questions, and there has to be another one for score. Well, we know that she answered 20 questions. So it's going to be x, the number she got right, plus this. So by analyzing the past pattern, she's probable to get 600 points. Okay. So I guess we're not including that other one. So she's trying to get 600 points. Her score, she's trying to get 600. So she saw it. She thinks she can get 600 points. Let's set this up. So, well, the first one is really simple. We can get that x plus 620, but oh, look, we're just looking for this. Wait, you notice that the average number of questions, 12 out of 20. Oh, so I guess there's 20 questions asked, but she's only going to answer about 12. So we're dealing with averages here. So she is only going to answer 12 of those questions, and she wants to get that 600. So she's betting that, oh, maybe I'll get 12. Let's see how many questions I have to get right. So X is right, Y is wrong. So we have X plus 12 should be our first one. Because I thought she was going to try to answer all the questions. She's like, nope, I'm only going to answer 12 of these questions. We don't have to bother about the other ones because there's no change. And she's like, oh, and I want to get like 600 points. So X is going to be the number of questions she gets right. So right questions are 100 times. So this is our right. X is equal to correct questions. I guess I should say correct. Correct. And Y is our incorrect. So in this case, our Y is incorrect. And incorrect, you lose 200 points. You're going to lose those 200 points, and we're going to do that. All right. So let me erase this. I don't need this anymore. I would do the erase the board, but then it kind of gets rid of all the work I do. So here I'm going to do 100x minus 200y. What's 100x minus 200y? But not 12, 600 points. So those are equations there. This equation is for the score, and this equation is for questions answered. So that's what it takes for her to get what she wanted. Oops, and I guess I can clear the board here. So now we're going to talk about viable options. So remember when I made that mistake and I'm like, oh, I guess we got negative, but sometimes that's okay, sometimes that's not. So we're going to talk about viable options. Obviously, what they're doing here is you can't have like half of a puppy here or half of a kitty. Can't have that. So, and I guess you could technically have half your hair cut like that, but for the most part, you don't want to do that. So you don't want things that aren't viable. You can't have half of, you can't go Frankenstein. I mean, this is viable, it's just not ideal. So there are some times where you have certain constraints. So constraints meaning things that like you want it to satisfy a specific condition. So let's go into this. Oh, that reminds me. If you guys need help with vocabulary, I don't go over vocabulary too much, but it is an important resource. So always check out this. You'll see here that it talks about viable and non-viable. That just reminded me of the guided notes. You can always pull out your guided notes, and if you're and to help you study, what you can always do is you can always copy this. Oops, no, not search the internet. No, why would you do that? I think I just got rid of my Edmentum. Okay, it didn't get rid of my Edmentum. I was so scared there for a second. You can just always copy this and just paste it onto your notes. And then for constraints, you can click constraints, copy this, paste that right onto your notes. An objective, you can always copy and paste the objective too. These are just useful to have when you're taking the test, so I do recommend doing it. Going on. So now we're going to check viability of solutions. So we're talking about someone wants to go on the rides and play games. So according to this, the ride or the games cost 5 tickets. The rides require 7 tickets, and he has 35 tickets. So this guy, like, I got 35 tickets. I want to do 8 activities. All right, so I want to do 8 activities. So he's like, I want to play games, and do rides, and I want to do at least 8 of them. And I'm gonna do it, even though the tickets cost this much. I can do that with 35. Yeah, I can do 8 activities with 35 tickets. Let's see how this goes for him. All right, so and then they did the thing I just did right now with doing all the 8 activities. All right, so I'm gonna clear this board. So we're gonna try to figure out if this is a viable solution. So we're gonna graph this because that's how we figured this out so far. So participate in that. So he wants to. Each game requires 8 tickets. 8 times tickets, 40. Oh, this is just talking about why this doesn't work. And the reason why this doesn't work is pretty obvious. Let's just say he doesn't even bother with rides because you know what, rides, they're kind of expensive. It's 7 tickets, so I'm just going to play 8 games. Wait a minute, that's 40 tickets. He can't do 8 activities because even if he does the cheapest activity 8 times, it still costs more than the amount of tickets he has. So this is just explaining why this isn't invaluable. What happens is these lines are going to cross to a point where he has to play like negative games to be able to do it, which doesn't make any sense. That's not viable. You can't play negative games. All right, so let's look at this, and we're going to see this. So our boundaries and the fourth. So we're going to see what our boundaries are. So in this case, let's see trip to Hawaii. So she needs to get those 600 points to get her trip to Hawaii. All right. Our boundaries for the first equation viable. What does this suggest about the 600 points? So remember, you think you'll respond to question in the scenario. All right. 600 points. Select boundaries of the first equation results in scores of this and this. The boundaries. Oh, so we're going to see what it means by boundaries in this case is it's talking about what happens if what's our biggest possibility and our least possibility. So let's say she gets all of her questions wrong. All of them wrong. We're going to do negative 200 times 12. All right, so what we're doing here for our boundaries, we're going to do the maximum of each number. All right, so negative 200 times 12. So 12 times 200. So that's why we get that negative 240. But guess what? It said the first equation. So that's more of our second equation, right? The boundaries of the first equation result in that which are both viable. Not viable for this. We want a trip to Hawaii and hope to score 600 points to win, although possible or even. So it's more of the second equation. So the lower boundary of the equation is not viable because they can't be negative scores. You can have negative scores. That is totally possible. You can have negative score. It's not good. So the upper boundary of the first equation results in a score less than 400 points, so the solution is not viable and won't win the game. Because 1200 points is greater than that. Okay. They keep talking about the first equation, and that's not the case. We're talking about the second equation. Points viable, a way to score the game, win enough with a wrong answer or two. So what they're saying here is, guess what? Because we have like so many points, like we should be fine even if we get a couple of wrong questions here. So I don't know why they keep talking about the first equation. This has to do with the questions answered. So this is the only one that makes sense to me, because if we get all the questions right, we get 1200 points. So let's pretend this. Our upper boundary is 1200 because we're going to assume the best case scenario. She gets all of them right. So even if she gets a couple wrong answers, we should still be fine. Oh, apparently it's a partial answer. I think they keep talking about the first and last equation. So because the upper boundary, the boundaries of the first equation, which are both viable, both situations aren't viable here. The lower boundary of the equation is not viable because there can't be negative scores. I mean, that's true. The score is less than that because lower boundary. What are you guys talking about, Edmentum? Why do you guys keep talking about the first equation? We're talking about the second equation. Here are the equations you wrote for the model stitching error. Are the boundaries of the first equation viable in the second equation? Oh, I see. They're saying that if this boundary is possible, so it is possible because our boundary is 12 right answers. So it is possible. So because 600 is greater than that, let me try this again. So our boundary is 12 correct questions. So the upper boundary, the lower boundary of this, which are both viable. Both of them aren't viable though, Edmentum. What are you talking about? The upper boundary of the first equation is less than 1200 points. It's not less than that. It's actually 12. Edmentum, what are you talking about? Let's try this because I don't know what they're talking about. Let's see what they're talking about here. They're not both viable. I'm assuming this, like, this is not viable to me. So to me, it's this. Technically, it's not viable for what we want. We don't want negative points. So they're not both viable. This one's just weird. They're just saying, is it possible to get this? Yes, you can technically get negative points. I don't know what Edmentum's talking about here. This should be the only right answer. Because if you want to win that vacation, you don't want this. That's not a. Oh, I see what they're saying. It's viable because it's possible, but they want you to. Edmentum, you need to be more clear with your things. Anyways, so let's see what we have here. So just review these, and I will make a Kahoot based off these questions. So if you're watching this after Monday, you're probably realizing why you should have watched this video before Monday. All right, guys, have a good one, and I'll see you for the next video that I'll probably post up in a little bit.